Welcome everyone to the deep dive. Today we're jumping headfirst into something huge, artificial intelligence.
Yep, it's everywhere.
It really is.
Yeah.
We've sifted through a ton of research, especially leaning on insights from Professor Theos Evgeniou at INSEAD. He's been in AI for, what, nearly 30 years?
Just about.
Yeah.
And advises big players like the WEF, OECD, so he knows his stuff.
Definitely.
So our goal for you today, it's really to cut through all the hype, all the noise. We want to pull out the essentials, give you that core understanding, and maybe the key questions you should be asking.
So you can navigate this whole kind of complex landscape.
Exactly. Think of it as a shortcut to getting properly informed. We'll cover everything from, what AI even is to the massive economic side, the risks, governance, the whole package.
Okay, let's do it. Let's unpack what AI actually is, how it's changing, what it can mean for, say, your business, and how the leading organizations are tackling it. So to really get AI, maybe we should start with the big thinkers, how they see intelligence itself.
Good starting point.
Our sources had some powerful quotes, like Demis Hassabis from DeepMind Nobel Prize winner just recently, right?
That's him, 2024.
He said, "Our goal is to solve intelligence, and then use that to solve the other problems of the world." Pretty ambitious.
Hugely ambitious. And then you've got Tommy Poggio at MIT saying something similar, like, the greatest of all great problems is the problem of understanding and engineering intelligence.
So it's not just about building smart tools, it's about cracking the code of intelligence itself.
Precisely. And that's where our sources bring in this idea called Mars vision.
Mars vision, okay.
Yeah, it suggests looking at complex systems like a brain or a computer on three levels. You've got the hardware, the actual physical stuff,
Right.
then the algorithms, the sort of abstract steps, and finally the computations, or like the overall goal or problem being solved.
Okay, hardware, algorithms, computation. And this leads to that provocative question, doesn't it? Is AI actually alien intelligence?
Exactly, because if you look through Mars lens, AI often uses totally different hardware, different algorithms, maybe even different computations compared to us humans.
So it's not just a faster brain, it's
Yeah.
something else.
Something potentially quite different, yeah. And when we talk about the intelligence part of AI, the research kind of boils it down to three core bits: data, compute power, and algorithmic ability.
Data, compute, algorithms, the ingredients.
You got it. And there's this related concept, minimum viable intelligence, MVI.
MVI, what's that?
It's basically asking, what's the minimum level of intelligence an AI needs to unlock a totally new product or service? Not human-level intelligence, just enough to be useful in a new way.
Okay. The threshold where it becomes genuinely valuable for something specific.
That's the idea.
So if that's the foundation, what about the economic impact? The numbers we saw were just huge.
Yeah, they're pretty staggering. Daron Acemoglu, another Nobel winner, 2024, again, he suggests the big impact comes down to, like, what fraction of tasks AI hits and how much cost it saves per task.
Makes sense. And the total value estimates.
Well, McKinsey back in 2023 was talking about maybe $20 trillion.
20 trillion.
Yeah. And Goldman Sachs more recently, this year, pinned $7 trillion just on generative AI alone.
Wow. Okay. That's transformative money.
Absolutely. Which brings up a really practical question for businesses, for you listening. What happens when your team is, say, X number of humans, and suddenly 10x AI coworkers?
Right. How do you even manage that?
You're looking at building whole new kinds of organizations, these hybrid humans plus AI's organizations. It changes everything.
And it's not just digital, is it? The research points out that things like energy, materials, rare earths, they're now part of the tech stack.
Yeah, the physical footprint is growing. It needs resources.
And there was that interesting point about innovation versus diffusion, like the German Nobel Prizes in chemistry versus MIT's chemical engineering degree.
Right. One is the breakthrough science. The other is making it usable, scalable, turning it into products and processes. That distinction is crucial for AI, too.
So it points to this global AI adoption race, figuring out who can actually use this stuff effectively.
Exactly. And that could really shift the global balance.
Now, AI isn't brand new, but it feels like it's fundamentally shifted. Our sources talk about 4 stages.
Yeah, a kind of evolution of artificial intelligence. Stage 1 was basically paper rules, human-based, didn't scale, not really tested properly.
Okay, simple rules on paper.
Then stage 2, computer-based rules, but still humans writing them. Scalable, yes, but still not rigorously tested. Humans did the thinking, AI just executed.
Got it. More automation.
Stage 3 is where machine learning kicks in. ML-based rules. Now, this is scalable, can be carefully tested, but usage was often limited, needed lots of oversight, risk management.
Okay, the machines start learning the rules.
And that leads to stage 4, where we mostly are now. Machine learning-based functions. Think speech recognition, computer vision, highly scalable, carefully tested, used everywhere.
Higher risks. More oversight needed. The black box problem.
Exactly. Often we don't fully understand how they reach their conclusions, so oversight and managing risk become even more critical. This whole progression shows a massive shift, right? From us telling the computer exactly what to do.
To the computer learning or even writing the program itself based on data.
Precisely. Old AI versus new AI in a nutshell.
And this leads to something really wild mentioned in the research. Vibe coding. What on earth is that?
Aha. Yeah, it sounds a bit out there, doesn't it? But imagine asking an AI, like, okay, figure out the rules to classify overdue loans, maybe build the decision tree, and then, and generate the Python code for that too.
The AI writes the actual code.
Increasingly, yes. Vibe coding is this term for when developers, because the LM is so good, they just sort of go with the flow.
Like, accept all the suggestions.
Pretty much. Accept suggestions, copy-paste error messages back to the AI to fix. The source even jokes you fully give in to the vibes, forget that the code even exists. It's maybe a bit hyperbolic, but it points to this trend where the code can grow beyond what any single person fully grasps. The AI becomes a collaborator in creation.
So AI isn't just doing tasks like classifying images or predicting the next word. It's changing how we create the systems that do those tasks.
That's a great way to put it. It's transforming the process itself. And that kind of shift from coding everything ourselves to, vibe coding. It makes you wonder, how do you even build a strategy around this?
Yeah, where do you start?
Well, the research points to AI foundation models as a new starting point, a new paradigm. Think of the big models coming out of Stanford, NVIDIA, places like that. They're like the bedrock now.
Okay, so building on these foundation models, what questions should you be asking for your strategy? The source had 5 key technical ones.
It did. One that really stood out to me was about managing your data supply chains.
Data supply chains, meaning?
Not just having data, but managing its whole life cycle. Is it available? What's the quality control? Who's accountable? Can you trace it back? Privacy, security, all that stuff.
Especially if AI is making decisions based on it. You need to trust the source.
Absolutely critical. Other questions were like, are you using both predictive and generative AI? Are you finding and using innovative data, maybe stuff others aren't looking at, internal or external?
Right. It's about data, model types, innovation. And developing the strategy itself is phased.
Yeah, the sources suggest a process. First, like, initiate and educate. Just days or weeks. Training, workshops, get everyone on the same page about trends.
Like baseline.
Then, bring clarity. This takes longer, weeks or maybe months. You define your ambition, your strategy, where the value is. Then, crucially, you identify and prioritize use cases. Value versus feasibility.
Don't just chase shiny objects.
Exactly. And finally, build capabilities, create and capture value. Assess where you are, find the gaps, build the models, the data platforms, do the training, foster the culture, and manage the risks and regulations. It's a journey.
And the emphasis was on building an AI portfolio, not just random projects, right?
Yes, definitely. Thinking bigger picture across 3 areas.
Okay, what were they?
First, process versus product. Is the AI improving your internal stuff, or is it part of what you offer customers?
Internal efficiency versus external innovation.
Second, task transformation. Automation versus augmentation. This is huge for the workforce.
That's where those stats came in.
Yeah.
Like 80% of workers having jobs with at least 10% task exposure to LLMs.
Yeah, and almost 20% having over half their tasks exposed. It's about changing jobs, not just eliminating them, augmenting human capability.
And the third dimension.
System redesign and the AI flywheel. How can AI fundamentally change whole systems, creating these positive feedback loops where it gets better and better?
Okay, process, product, task transformation, system redesign. And prioritizing within that portfolio comes back to value versus feasibility.
Right. Balancing the potential upside against, do we have the resources? Is the data good enough? Do we have the skills? Is the pattern even predictable enough? That's the minimum viable accuracy idea.
Minimum viable accuracy, another MVI.
Yeah. Lots of MVIs. But the key takeaway here was think in portfolios, not pilots. Use a maturity matrix, maybe allocate percentages. Some budget for experiments, some for quick wins, some for long-term strategic bets, a balanced approach.
Okay, that makes sense strategically. But how does this look inside an organization? The sources had that Eon case study, the energy company.
Yes, Eon, and a really practical example of a big company going through this data and AI transformation.
What were the key lessons from them?
Several things. Crucially, they had strong backing, like real support and protection from the board, top-level commitment.
Not just an IT project.
No, a strategic priority. They also hired talent everywhere, trained people across the board, and they went for quick wins early on, high-impact, low-data hurdles to build momentum.
Show progress quickly.
Exactly. And they really pushed what they call data evangelization, actively showing people the value, answering the what's in it for me question.
Making it real for employees.
Yeah, they even created a central initiative, Data On, with local hubs, a community, plus strong data governance for quality, clear roles, accountability, and clear processes for deciding where to invest in AI.
Sounds comprehensive.
Yeah.
So what are the big takeaways for any organization trying to get better at AI?
Well, first, it's a cultural change, not just adding tech skills. That came through strongly.
People first.
Second, balancing impact and capability building. Avoiding those isolated mushroom projects by having standards so things can scale.
Right, to avoid pilots that go nowhere.
Also, the funding model is critical. How you pay for this shapes the roadmap. And data evangelization and upskilling are non-negotiable. Plus, you need that mix. Top-down support for momentum, bottom-up engagement to make it stick.
And architecture, standards, prevent it becoming a fragmented mess.
Absolutely. And finally, every company needs its own tailored strategy, no one-size-fits-all solution.
Based on all that, the sources had 5 organizational questions for listeners to ponder.
They did. Really good ones to ask yourself, like, what is your AI funding model? Does it match where you are on your AI journey?
Good question.
Are you balancing spending on immediate use cases versus building foundational capabilities for the future? How do you handle central versus local teams for AI? Do you really have a clear data strategy and governance? And critically, do you have the right people in the right roles?
Lots to think about there on the organizational side.
Okay.
Strategy, organization. But what about the risks? AI isn't all upside. Governance is crucial.
Paramount. AI governance, as the sources define it, is basically ensuring AI use lines up with your strategy, goals, values, legal stuff, ethics, everything.
So how do you actually do governance? What are the parts?
It's a framework. You need clear principles like safety, privacy, non-discrimination, explainability.
The guiding stars.
Then policies like rules on transparency or when human oversight is mandatory. You need defined roles, who's responsible. C-suite, compliance, data teams, product owners.
Clear accountability.
Essential. Then processes things like risk assessments, testing procedures, building safety in from the start, X by design, communication plans. And finally, tools AI registries to know what systems you have. Monitoring tools, incident reporting, compliance checks.
So it's a whole system built into how you develop and deploy AI.
Exactly, from the very beginning right through to putting it out in the world. Values aligned at every step.
And the sources had 5 key risk and governance questions too.
Yep. Critical ones. First, do you even know what AI systems you have, and are they risk managed? Just basic visibility.
It sounds obvious, but probably isn't always easy.
Often isn't.
Yeah.
What new risks, business risks, regulatory risks are you facing because of AI? Which systems are causing them? Do you actually have an AI governance blueprint?
A plan for managing it all.
Right. And what regulations, like the EU AI Act maybe, affect your strategy? How are they changing? And importantly, are there longer-term second-order risks you're maybe not seeing yet?
Thinking ahead.
And this whole area is full of tricky trade-offs and dilemmas. The research really highlighted these. Like what?
Well, choices between moving fast versus being cautious. Pushing for productivity versus managing disruption. Privacy versus security, a classic one. Trust versus safety. Transparency versus protecting your intellectual property. Automation versus the impact on your workforce. There are no easy answers here. It's all about balancing competing needs.
It really drives home that AI needs this incredibly broad, holistic view, doesn't it?
Totally. It pulls together math, science, data engineering, sure, but also human behavior, IT, organizational change, law, ethics, geopolitics, even history.
It's everything. Wow. Okay, so we've gone from the fundamentals, what AI is, its economic potential through its evolution strategy, how to organize for it.
Right up to the critical governance and the risks involved.
That's been quite the journey.
It really has. And it's clear, isn't it? AI isn't just another piece of tech. It's a massive shift for society, for
A
organization.
genuine transformation.
We've really only skimmed the surface today, despite the depth. But hopefully, this deep dive gives you a solid, actionable foundation, something to build on. Definitely. And as you listening, think more about this incredible frontier, our sources left us with some really provocative final thoughts to mull over.
Yeah, some big questions.
Like, what impact could AI have on our social norms, our institutions, things we just take for granted?
And fundamentally, what objective function is AI really operating with? What's its goal?
What does AI even perceive? Is it seeing reality in ways we don't or can't?
Could it perceive things humans miss entirely?
And thinking about the future, what would AI-enabled best friends look like? Especially for kids.
That's a deep one.
And ultimately, maybe the biggest question of all. In a world increasingly shaped by AI, what will it mean to be human?